Hello, welcome back for the video for lesson 7.2. We are going to learn about the law of cosines today, where in 7.1 we learned about the law of sines. So the law of cosines says that we have a triangle A, B, and C, and we don't have a figure here, but we are, you'll see it in your book, where we're missing the side A. So we know the angle A and the two sides B and C, or we know angle B and the two sides A and C, and likewise we know angle C or the two sides A and B. And if we know those two sides and the one angle, we can find this side opposite the angle. Okay, so the law of cosines is used to solve a triangle when either of the following set of information is given. So if you know two sides, a side, and then the enclosed angle in a side. So let's say we know A, and then we know B and C, but we don't know little a. Okay. That's side, angle, side. Or if we know all three sides, we can then use this law of cosines. Let's look at a few examples. A says, the law of cosines, example 1, use the law of cosines to find the unknown side of each triangle. So we're given A, side C, and angle B. So this time, we want to find the side C. So find side B, sorry. So find B. So we are going to say, we know that B squared is equal to A squared plus C squared minus 2AC, the cosine of angle B. Okay, we know that from the law of cosines up here. And so we know that B will equal the square root of that. So the square root of A squared, so 12 squared plus 8 squared minus 2 times 12 times 8 times the cosine of 56. And we can put this directly into the scientific Desmos. So let's share our screen here so we can show you what that looks like. Let's just click here. And then we can go to the scientific calculator. Okay, so we're going to say we're going to take the square root of, and we're going to do 12 squared plus 8 squared minus 2 times 8 times 12 times the cosine of 56. And there's our answer. So the length of side B is 10.03. So I would go to 1 or 2 decimal places. So there's the length of side B. Okay. The second example, we know side A and side B and then angle C. So we're trying to find side C. So we know that C is equal to the square root because we're taking the square root of a square. So C is equal to A squared plus B squared minus 2AB cosine of the angle C. So that's going to be 10 squared plus 5 squared minus 2 times 10 times 5 times the cosine of 102 degrees. And when we put that into the scientific Desmos, and the cool thing is we can just edit these. That's 102. And the length of the side C is 12.07. So there, it's 12.07. Okay. Example 2 says solve each triangle, meaning find all the missing angles and the side lengths. So this time we're going to find the missing angles as well. So first, because we know angle A, we're going to find side A. So that'll be the square root of 10 squared plus 7 squared minus 2 times 10 times 7 times the cosine of 55. And if we put that into the scientific Desmos, we get A is equal to 8.29. Okay, so we know one angle. We know angle 55. Now that we know side A, we can use our law of sines to find the other angles. So we know, and remember, law of sines is A over the sine of A equals B over the sine of B equals C over the sine of C. And we know 8.29 over the sine of 55 will equal 10 over the sine of B and 7 over the sine of C. So we can find, to find angle B, we know that 8.29 times the sine of angle B equals 10 times the sine of 55. And then if we divide by 8.29, and notice that I'm just kind of leaving it all uncalculated, because if you type it exactly what you're going to calculate, it's a more accurate answer. And so to find B, we're actually going to take the inverse sine of this. 10 sine of 55 over 8.29. And I'll show you what that is. So let's go to scientific Desmos. And we're taking the, first we have to tell it inverse sine. And then go back to, and the thing we're taking the inverse sine of is 10 times the sine of 55 divided by 8.29. And that is angle B is 81.16 degrees. And they have to equal 180. So we could do 180 minus 55 we were given, minus the 81.16 that we just found. So we know that the angle C should be about 43.84. But I'm going to show that actually using our law of sines. So our law of sines says that 10 times the sine of C will equal 7 times the sine of, oh, sorry. We're going to use the one we were given because that's the more accurate. So it's 8.29 times the sine of C equals 7 times the sine of 55. So going through the same process that we just went through, we know that C will equal the inverse of sine as 7 times the sine of 55 divided by 8.29. 629. So the only thing that changes is the 7. So I'm just going to go back to my scientific Desmos here and change this to be a 7. And so this gives the angle of C as 43.76. So if we added, we were given 55 and we calculated B to be 81.16 plus 43.76. It rounds to 180. So we could maybe round 81.16 to 81.2, and then we would round 83.86 to 83.8. And there we go. I'll take you back to my paper there. So I'm going to round this one to, this one to 81.2, and then this one to 43.8. Okay. Now, under B, I'm giving you just the 3 sides of the triangle, and we're going to find the 3 angles. So I'm going to start with C, just because. So I know that C squared equals A squared plus B squared minus 2AB, the cosine of angle C, which we don't know. So little c squared equals this. So we know little c, you know A, and we know side B. We just don't know angle C. So 144 equals 16 plus 81 minus 72 times cosine angle C. And then if I subtract the 16 and the 81 from both sides, I get 47 equals a negative 72 cosine angle C. And divide by a negative 72, and I'm going to not actually calculate that quite yet, just to keep things accurate. And so to find this angle, I'm going to use the inverse cosine of, so angle C will equal the inverse cosine of a negative 47 over 72. And if we put that into scientific Desmos, negative 47 divided by 72 is, angle C is about 130. I'm going to round it to 130.8 degrees. Then, now that we know that, we can use that angle and the law of cosines to find one of the other angles, and then we can subtract from 180. So I'm going to find angle A. So we can, so to find angle A, we've got A squared equals B squared plus C squared minus 2BC cosine of angle A. And I know, so we got 4 squared equals 9 squared plus 12 squared minus 2, 9, 12 cosine A. So 16 equals 81 plus 144 minus, what is this, 108? So 216. Cosine A. And so we could actually kind of just work backwards and write this as the inverse cosine with these symbols here. So we're essentially taking the inverse cosine of a squared minus b squared plus c squared all over a negative 2bc is essentially what we're doing when we're solving for an angle. So if we go to scientific Desmos, we can just say inverse cosine, and I'm going to do a squared, so it's 4 squared minus parentheses and do 9 squared plus 12 squared parentheses divided by, oops, I want that in parentheses so that I can do everything in the denominator then, a negative 2 star 9 star 12. Okay. And so angle A comes out to be 14.6 degrees. So if I take 180 and subtract what we got for angle C, 130.8, and subtract what we got for angle A, 14.6, that leaves us with angle B to be approximately 34.6 degrees. So we calculated angle C, we just calculated angle A, subtracting from 180, we get angle B. So we can also use some of our properties here of trig to find the area of a triangle. So if we let ABC be a triangle with sides of lengths A, B, and C, if 2 of the sides and the included angle are known, then we can solve for the area. So we need side, angle, side, 2 sides and the included angle. And so it says find the area of the triangle with the side lengths of A 35, B 16, and angle 77. Okay, so we're going to use this right here. So the area equals 1/2 AB sine of C. So we have 1/2 of 35 times 16 times the sine of 77. And when we put that into scientific Desmos, we get the area to be 270. That looks like another 7, 272.82. We've got another one. We've got sides A and B and inclusion of C again. So the area here would be 1/2 times 19 times 8 times the sine of 124. And so that is 4, so that is 76 times the sine of 124. Let's show that one. I'll show A quickly, since I didn't have that. 1/2 times 35 times 16. And then times the sine of 77. That comes out to be the 272.82 that I just had for the first problem. And then we have 1/2 times 19 times 8 times the sine of 124. And so that comes out to be about 63. Okay. Let's go back to my paper here. So there is the area for example 4. And we have one last method of calculating the area of a triangle if we're just given 3 side lengths, like Aaron's formula. And the area can be found as taking the square root of s times s minus a times s minus b times s minus c. And s is a calculation of 1/2 times a plus b plus c. So we first have to calculate s, and then it's the differences here. So find the area of the triangle with side lengths a equals 7, b equals 10, and c equals 13. So we have to find s first. So that would be 1/2 of 7 plus 10 plus 13. And so that's 1/2 of 30 or 15. So that's S. So the area is equal to S times S minus A times S minus B times S minus C. So 15 times 8 times 5 times 2 is the square root of 15 times 80 equals 34. Make sure you can see it, 34.64. And the last lesson of chapter 7, the last example of chapter 7 is an area with the Heron's formula using these 3 sides. So again, we have to find the measurement of S, which is 1/2 times A, B, and C, which comes out to be 11.2. And then to find the area, it's the square root of S, and then S minus A, and then S minus B, and then S minus C. And I'm going to put this into Desmos, either Desmos or Desmos Scientific here. I have Desmos Scientific pulled up, so it's just as easy. So 11.2, parentheses 11.2 minus 5.4 minus 8. And I come up with an area of 16.91. And that was the last example for lesson 7.2. And we're only doing 2 lessons for chapter 7. So catch me back for the couple of lessons we're going to do for chapter 9.